Hi everyone, thanks for being here in the morning. Let me start with a question. Can you spot the bug on this screen? Here, the distance label is not completely visible on screen. I had this back in 2021 when I was a young React Native developer. But what's interesting with this bug is that I keep seeing it on many React Native projects. Each time there is a text in a row with an icon beside it, somewhere the icon or the text ends up being cropped. So what did I do back in the day? I went to Stack Overflow. Visibly, I was not the only one to ask. Today, I will probably ask ChatGPT, and I'm happy to share that both of the tools share the same answer. You have to add a flexShrink to the text. And this is what I did. This is my PR from back in the days, and as we can see now, the distance label completely displays on screen. The flexShrink parameters allow the text to reduce along the main axis to fit between the icon and the border of the screen. But why was the text too big in the first place? What did we have to add the flexShrink? This is what we are going to see today, and it's more interesting than you think. So, my name is Delphine Bugner. I work as a software engineer in BAM in Paris. I love to draw, so you may have seen one of my sketches on Twitter. I also love to dig under the hood of React Native stuff. And here, under the hood of this tiny bug, is one key player of the React Native game called Yoga. So Yoga is a layout engine used in React Native. It means that from a JSX tree and simple style rules, it's able to generate the positions of absolutely everything on screen. Every width and height, top and left, for every boxes we can see. Quite magical, right? But how is it even possible? How does it work? And where, inside of the Yoga code, is the bug origin? And most importantly, why was it coded like that, confusing what I say generation of React Native developers? This is the Yoga Enigma we are going to solve today. But first, a bit of history. Yoga was first created back in 2015 by Christopher Shadow, back in Meta. You know, it's a guy who created Excalibur and Prettier, pretty famous. It was like the early beginnings of React Native, and they needed something to manage the layout for iOS. What they had was UIKit. You may know it. It's hard to write. It can explode if you do not pay attention, so they did not want to use it. What they did like was the Flexbox model used in CSS. It's very declarative and atomic, so very React. It's also very React Native, because every web developer knows about it. So it respects the rule, learn once, write anywhere. So they did it. In 2 weeks, they recorded the flex algorithm from CSS, like, too easy, right? They did that using test-driven development, crafting the craziest layouts and adapting the algorithm until we returned the good result. And then in 2016, Facebook rewrote it in C++, extracted it from React Native, and open sourced it under the name of Yoga. By doing that, they made it platform agnostic. It means you can actually use Yoga with something else than React Native. Like, for example, it's used in this Swift library called Litho, or for Android using Component Kit, or even with non-native renderers, as in React PDF. But let's go back to React Native. How does it integrate in the workflow? What's a workflow? As I said earlier, everything starts with simple JSX and style rules. From there, React creates a tree of elements in JavaScript. Then, in the old architecture, the read is used to communicate with the native and create exactly the same tree, but with native components in Java and Objective-C. Also in the native, a third tree is created called the shadow tree. The shadow tree will be responsible to communicate with Yoga. So it receives the style information, but only the ones that are relevant for the measuring part. It doesn't receive the color, for example. You don't need to know a view is red to position it on screen. This is why I think it's called the shadow tree. It's full black and white. Then, finally, a fourth tree is created. It's not a workflow, it's a forest. The Yoga tree with C++ in the C++ layer with Yoga nodes. They also receive the style and screen dimension information, and you can also attach to the last node in the tree a measure function if you still want to use native methods to measure it, like for images or text. Yoga runs, computes everything, give it back to the native tree, and then finally, everything is painted on screen. In the new architecture, as you know, bridges are no longer a thing. We use what we call GSI to communicate with the native. And GSI, well, it's C++, so now the shadow tree lives directly in the C++ layer, which authorizes to mutualize even more code between iOS and Android, which I think is pretty cool. It communicates with the Yoga tree directly from there, but then the rest of the story is the same. Every dimension that computed, give it back to the shadow tree, native component tree created, and everything is painted on screen. The block that hasn't changed between the old and the new architecture is the one that interests us today, like the Yoga algorithm. How does it work? This is what we are going to detail. The main function in Yoga is called calculate layout. You apply it on the root node, and yeah, that's it. You don't need to do anything else. You've got everything you need. So you're the after party, folks. No, of course. I'm going to detail a little more. First, because calculate layout is not any function. It's more than 2,000 lines of C++ code. Then, because only after a few steps, it calls itself. So, who's measuring you? How to break the cycle? When do we end the recursion? Let's take things in order, slowly. What I did is to create a very simple app using Expo, thanks, with only the 4 nodes, like the root node taking the white background, taking all of the screen space, centered in it a work container with an icon, which is just a fixed-sized view, and the text beside it. As we can see, the text is overflowing out of the screen. And then I added some breakpoints inside the Yoga code to see the actual values taken by the variables and constants to have an accurate depiction of what was happening of the 11 steps of the Yoga algorithm. So, let's start. As I said earlier, everything starts by applying the calculate layout function on the root node. The function and the node will already receive 2 arguments from its parent, or here the context, because we are the first node in the tree, so it's basically the Yoga initialization. First, the space the node can take, the available space. And second, how should the node, here, because we are at the root, it's basically the screen. And second, how the node should behave compared to its parent. Should the node fit to its parent and fill the whole available space? This is what Yoga called the measure mode exactly. On the contrary, should the node fit to its content, to what's inside? For example, if it's centered inside of its container, like for the row container, this is what Yoga calls the measure mode undefined. There is a third measure mode called at most, where you also fit to what's inside you, as long as it's smaller than your parent. Then you start fitting to your parent. to not overflow it, because you're always constrained by your parents if you're not in a scroll view, for example. Well, we have finally everything we need to start the computation. Available space screen, and because of the flex1 parameter, we all have to fit to our parent for width and height. First step of the calculate layout is just collect all the values we need in the node. Second step is to compute the real available size, like subtracting the margin, padding, applying the min and max constraints. We don't have them here, so we don't have to focus on this part. And step 3 is to check whether you have children or not. And if you have children, you have to measure them at step 3. So, yeah, by calling yourself, so let the recursion begin. We move down to the raw container. And here, the available space is still the whole screen because we have no constraints. For the width, we fit to the parent because of the stretch behavior. And for the height, we fit to our content because we are centered. But after that, it's the same. Because we have children, we first have to measure them before doing anything else. So let's move down to the icon. The icon, it's a bit different. It's a fixed view size. So here, the available space is basically the one given by the style properties. And for the behavior, we just have to fit to it. So for the icon, calculate layout is pretty straightforward because we have no children. It's like an early return of the function. We get out of the cycle, finally, and call this get layout for empty container function. And guess what it returns? Like, yeah, 50-50 for the icon. We could have guessed that from the beginning, but it's the first node we actually finished to measure, so we can be pretty happy of ourselves. Going to the text node. For the text, available space is still the whole screen because there's still no constraint on it. The height, we always fit to the content because it's the same of the parent. And for the width, well, we are an element in a row. And when you're an element in a row, you also fit to what's inside you. But do you remember, when we built the yoga tree, there's actually, before checking whether we have children, we check whether we have a measure function coming from the native. And if we have one, we also break the cycle and directly enter into the get layout with measure function result. So this is what we do for the text. We go back to the native, but with the constraint given by yoga. What we do is basically drawing a rectangle of the size of the screen. Here, of the size of the available space, so here's the screen. Put the text inside of it, inject all the properties from React Native, like font size or max number of lines, and finally calls a native measure function on iOS called UIKit.useRect for text container, or on Android, static layout builder.obtain. Be careful, those functions are quite expensive to run, but they return exactly what we need, the width of every line and the height of the whole text. The final dimensions that are sent back to Yoga are the following, like height 72 and width 2137. No, wait. Width 361. Yeah. And we can finish. Oh, we have our text. But we also have the where of our Enigma. We measured the text with a much larger container than needed, like the whole screen. Why did we do that? At the point when our parent called us, we had no information from what was around us. The information from the icon size has not moved up the tree yet. So basically, the text took its whole parent size. And this is what we see. This is why it's overflowing. So we have the where of the bug origin. Let's finish the how part and going through the whole tree. We moved up to the raw container, and let's discover the last step of the calculate layout function. After step 3, There is step 4, collects flex lines together. It's basically the flex wrap property of the style. We don't have, so let's not focus on that. Step 5 is to deal with flexible children. We don't have them, so we can skip. Step 6 and step 7 are here for the justify content and align items properties. I won't extend on that, but do know that it is the part where we calculate the top and left for our children. Step 8 is still something with flex wrap, and we still don't need it right now. Step 9 is to compute and gather everything from what was before. And step 10 and 11 are for absolute children, so let's skip it too. And yeah, finally we did it. We've been through the entire calculate layout function. Congrats to us. So for our final dimension, as we had seen, width fits to the parent. So basically it's the screen dimension, and the height fits to the content, so the biggest of our children, so here, 72. We're done with the row. Let's move up to the road container, where simply during the step 9, we have to apply what we know fit to our parents because of the flex1 property. So actually it was the easiest computation to do. But as we have seen, calculate layout on a node is not only responsible to measure the node itself, but also to trigger the computation for all of the nodes in the tree. Yeah, we have the full how of yoga. We've been through the entire tree. We measured it. We have also been through all of the steps of the calculate layout function. And we also have talked a bit of native measures. To finish and go further in the how, I want to talk about what happens when you apply the fix, the flexShrink 1. And it will also help us answering the why, the most important one. Back we went on the row, coming down from the children computation, with flexShrink 1, we cannot skip the step 5 anymore because we have a flexible children. So what we do is basically compute what is called the remaining free space by subtracting to our available size the size of our children. And it gives us a negative remaining free space. Yeah, of course, we are overflowing. We are already too much, too big. We have to reduce them. So it means going back into our tech children and remeasure it, but with a smaller container adapted. So basically here, available space is screen minus the icon size. We go back to the native, draw another rectangle smaller than the previous one, reapplying our native measure functions, and get the new dimensions. Rest of the algorithm is the same as before. We move up in the tree, like it's basically the same also. If the text had wrapped more, the height would have been bigger, but here we stayed on 3 lines, so it's still 72. And yeah, also the same for the root. So, we've been through we've been further in the how part of the Enigma. We've been through the entire flex algorithm with flexible items, and we also have the bug fix origin. Pretty cool, but we still miss the why. Why was it coded like that? Yeah. And at this point, I asked myself, there's a place where I never need to add flexion 1. It's on the web. This is the same layout with HTML and CSS elements. And the text completely wraps, and I haven't added any flexShrink, so I was like going down the W3C specification, trying to find like specific stuff in text CSS, and yeah, doing crazy plans. No, it's much simpler than that. On the web, flexShrink equals 1 by default. I completely forgot about that, proof that I've been a React Native developer for so long now. It's actually one of the very few differences that the Flexbox model makes compared to the CSS one in React Native. So why did they do this decision? And the answer behind is something we really like in BAM. It's for performance. as I said, measuring text in the native side is quite expensive to run. So the whole yoga algorithm has been conceived and written to minimize the amount of time texts are measured. What we have seen when we had flexShrink 1, we had to measure the text at least twice. First with the whole container, and a second time to adapt it to its context. Twice is one time too much. Therefore, the decision to resolve flexShrink to 0. And even with this setup, someone from the yoga team said that measuring text takes up to 50 from 60% of the whole yoga time, yoga execution time. But as I said earlier, yoga is platform agnostic, and we're approaching the end of the talk, I swear. Oh, yeah, sorry, we have the full way. Let's celebrate this. We're happy to have found out about that. And the real culprits are, yeah, those guys. Their native function, so expensive to run. Congrats to them. Now, as I said, yoga is platform agnostic, so there's actually a settings called use web defaults. Inside of it, you can activate, and guess what it does? It restores flexShrink 1 by default. As you also know, Yoga 3.0 has been out for a month now with Reg Native 74. It introduced a small change. It's changing the margin position in row reverse mode. It might be just a detail for you, but it's actually a step into the direction of more web conformity, like to be more universal. And this is the path yoga is taking. Following the universal standards, will they find a way to measure native text faster and turn flexShrink 1 for every React Native developer? No, they won't, because it will be like a major breaking changes for everyone. But what they did promise to us is to offer us more configurability in the future. And this will be my last sentence. So you, as a developer on your project, can choose which power of yoga you unlock. So, thanks everyone. This was the Yoga Enigma. Enjoy the rest of the conference.